This is a video about the absolute value section and doing inequalities with absolute values. So first I want to start with an example from section 2.5 that we talked about last week. Caleb had a pet sitting business and he charges $32 an hour. His expenses each month are $2,272. How many hours does he have to work in order to earn a profit of at least $800 a month? So we talked about setting up a variable, the number of hours he's going to work, and the inequality is his profit should be greater than or equal to 800, at least $800. So that a formula for the profit is 32 times x, $32 per hour times x hours, minus his expenses, 2272, should be at least 800. So we solve that. We add 2272 to both sides, divide by 32, and we end up with 96 hours. I want to change the problem, though, to say instead of getting at least 800 per month, what if he decided he needed between 700 and 900? So he had a range instead of a minimum. You can do the same sort of thing, except now we get a between statement. And the inequality is going to be a compound inequality. And $700 should be less than or equal to the profit, which would be less than or equal to 900. And like we talked about, you could break that into two inequalities, or you could leave it as one compound inequality. But we can now take our formula for profit and plug that into the inequality and get this statement with the in-between part is 32x minus 2272. We add 2272 to both sides and divide by 32 just like we did before, and we end up with 92.875 is less than or equal to x is less than 99.125. So the number of hours he should work is in that range, a little less than 93 to a little bit more than 99. How can we think about that as an absolute value, though, instead of a compound inequality? Well, what you can do is think about the range of the solution. The range is between 700 and 900. So another way to think about that is down here. You want to target at 800 as your midpoint of your range, plus 100, minus 100, up to 900, down to 700. And so you can think about this inequality as saying, I want my profit to be about 800, but up to 100 above it and up to 100 below it. And so you can take that inequality that we had before, the 700 less than the profit is less than 900, and subtract your midpoint, your 800, from each of those parts, and you get negative 100 is less than the profit minus 100, so that's how far away you are from your target, should be less than 100. And when you've got, that's exactly what an absolute value does. If you take the absolute value of the profit minus 800, that should be less than 100. And that profit minus 800 is kind of your, how far off from your target value you are. And you want that to be less than 100. And you don't care if it's less than 100 on the positive side or on the negative side. That's where you have the less negative 100 to 100 for your absolute value inequality. And so that's one way to think about absolute values as giving you a range around a target. So you want to target in on 800 and be less than 100 to the right or less than 100 to the left. And that gives you between negative 100 and 100 away from 800. So let's do one of the examples that's similar to what they have in class in the textbook. Absolute value of x minus 12 is less than or equal to 5. I'll show you how to solve that algebraically, and they do that in the textbook. But I also want you to think about it as this is kind of your target. And x minus 12 is how far away you are from 12, and you want that to be less than, at most 5, less than or equal to 5. So your range is going to be, if you think about it on a number line, you're going to have your midpoint of 12, and you want to go at most 5 to the right, at most 5 to the left, and that'll be from 7 to 17. How do we solve that algebraically? So that's the way you should think about absolute values and how they're most often used. The way to solve it algebraically is to think x minus 12 absolute value is less than or equal to 5 means it's between, and I want to see people thinking about doing your hands like this. Say it's between, it's less than 5 on either side. So it's between negative 5 and 5. But what is? X minus 12 is between negative 5 and 5. So then you add 12 to both sides and you get 7, or not to both sides, so all three parts. And you get 7 is less than or equal to x is less than or equal to 17. the same inequality we had up above when we thought about it on a number line. One difference they talk about in the book is what happens if it's greater than 5, a greater than or equal to, like here we have greater than or equal to 5, same equation. Then you want the distance from 12 to be at least 5. So your solutions are going to be on the outside, either farther away than 5 to the right or farther away, so more than 5 to the left of 12. And so that's going to be below 7. So 7 and everything to the left of that. Or on the right-hand side will be 17 and everything to the right of that. And that should just be kind of in your head, how you're thinking about, how you're visualizing absolute value problems. You don't have to write all that out, but it does help to kind of think about it that way. So if you think about when you've got an absolute value that's a greater than, there's two possibilities. It's positive, farther to the right, or it's farther to the left. So if there's two possibilities, you're going to have two inequalities. And they're here. You're going to have either whatever was inside the x minus 12 is farther to the left than -5, or it's farther to the right than 5. So you get two inequalities, and you can solve them by the same algebra we've been doing the last little bit. But when you finish, you're going to get two intervals in almost every case. You're going to get one interval that's 7 and everything less than that, and you're going to get one interval that's 17 and everything to the right of that, everything more larger than 17. So if you think about absolute value being bigger than 5, that's a farther away than 5 units away from the midpoint. And so that visual, that hand movement really helps you figure out that it's two intervals, whereas if it's less than 5, it's constrained and it's less, the distance is less than 5 on either side. So I wanted to do one kind of real world application. And so suppose, for instance, that there was a vaccine that had to be refrigerated and kept between -1 Celsius and 9 Celsius. And anytime you hear between, you want to start thinking about absolute value inequalities. So what's the inequality in this case? We're going to have -1 is less than C is less than 9. They tell us that it should be between -1 and 9. So let's say the temperature in Celsius, which we'll call C, is -1 is less than or equal to C is less than or equal to 9. Well, how can you kind of modify that to be a midpoint? Well, look on a number line. And if you have 0 here and -1 here and 9 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, where's the midpoint? Where's the midpoint for that, that interval? Well, if you take the average of the two, 9 plus -1 over 2 is 8 over 2 is 4. So the midpoint, 1, 2, 3, 4, is going to be right there at 4. And from 4, it's 5 units up to 9, and it's 5 units back to -1. So you can describe this interval as centered at 4, up 5 or down 5. So I want the temperature should be 4 degrees Celsius plus or minus 5 degrees Celsius. And that'll go from 4, it'll go up to 9 or down to -1. So if we think about that inequality as the -1 is less than or equal to C is less than 9, if we try and use the midpoint part of that, what if we subtract 4 from each part? -4, -4, because 4 is the midpoint. We're going to get -5 is less than C minus 4 is less than 5. And if you've set it up right, if you've chosen the correct midpoint, these two, the 5 and the -5, will be negatives of each other. And so that is set up to be C minus 4 is less than 5 in absolute value. And that you want to think about as 4 is the center. So this 4 is the midpoint. And this is the plus or minus. In the book, they call it the tolerance or the error. So you want to be within that range, centered at 4, up 5 or down 5. And you can set up an inequality like that as an absolute value in lots and lots of cases.